Download this code from codegive.com, link in the description below. Python Inheritance, a comprehensive tutorial, based on W3Schools. Inheritance is a fundamental concept in object-oriented programming, OOP. It allows you to create new classes, called child classes or subclasses, that inherit properties and behaviors from existing classes, called parent classes or superclasses. This promotes code reuse, reduces redundancy, and makes your code more organized and maintainable. This tutorial, inspired by W3Schools, will guide you through the ins and outs of Python inheritance with detailed explanations and practical code examples. Why use inheritance? Imagine you're creating a program to manage different types of vehicles. You might have a class called vehicle that contains common attributes like make, model, year, and methods like start_engine, stop_engine. Now, you want to create car and truck classes. Instead of rewriting the code for make, model, year, start_engine, and stop_engine, in each class, you can make car and truck inherit from vehicle. This way, car and truck automatically get all the attributes and methods of vehicle, and you can then add specific attributes and methods relevant to each type of vehicle. Example number _of_ doors for car and towing _ capacity for truck. Basic syntax. The syntax for inheritance in Python is straightforward. The child class, parent class, part is key. It indicates that child class inherits from parent class. Example 1, simple inheritance. Let's start with a very basic example. Explanation asterisk. Asterisk person class asterisk this is our parent class. It has an __init__ method to initialize the first name and last name attributes, and a print name method to display the full name. Asterisk student class asterisk this is the child class. It's defined as class student, person, meaning it inherits from person. Asterisk pass statement asterisk the pass statement in the student class means that it currently doesn't have any attributes or methods of its own. However, because it inherits from person, it automatically gets the first name, last name, and print name methods. Asterisk object creation asterisk when we create a student object, y equals student, Mike, Olson, it automatically calls the __init__ method of the person class, because student doesn't have its own __init__ yet. The student object y now has the first name and last name attributes. Asterisk method call asterisk when we call y.printName, it uses the printName method inherited from the person class. Example 2, adding to the child classes __init__ method. Often, you'll want to add more attributes that are specific to the child class. You can do this in the child classes __init__ method. Explanation asterisk. Asterisk child's __init__ asterisk the student class now has its own __init__ method that takes fname, lname, and graduation year as arguments. Asterisk initializing parent attributes asterisk crucially, within the student s__init__ method, we must call the __init__ method of the person class to initialize the first name and last name attributes. We can do this in two ways. Asterisk person __init__ self, fname, lname, asterisk this directly calls the __init__ method of the person class. You must explicitly pass self as the first argument. This is older syntax and is still valid. Asterisk super, .__init__ fname, lname, asterisk this is the recommended and more modern approach. Super, returns a temporary object of the parent class, allowing you to call its methods. It automatically passes the self argument, making the code cleaner and more robust, especially in multiple inheritance scenarios, explained later. Adding new attributes. We then add the graduation year attribute, which is specific to the student class. Welcome method. We also added a new method, welcome, that is specific to the student class. Example 3, adding methods to the child class. You can also add new methods to the child class that are not present in the parent class. Explanation. Dog class inherits from animal. Fetch method. The dog class has a fetch method that is specific to dogs. Method overriding. The dog class also has a speak method. This is an example of method overriding. The dog class's speak method overrides the speak method of the animal class. When you call dog.speak, it executes the speak method defined in the dog class, not the one in the animal class. Inherited attribute. The dog class inherits the name attribute from the animal class. The dog class's __init__ method implicitly calls the animal class's __init__ method because dog's __init__ does not redefine it. If dog had its own __init__ it would have to explicitly call the parent's __init__ using super.__init__ to properly initialize the parent's attributes. IsInstance, and is subclass. Python provides built-in functions to check the relationship between objects and classes. IsInstance, object, class info, returns true if the object is an instance of the class info, or a subclass thereof, and false otherwise. Is subclass, class info, returns true if class is a subclass, direct or indirect, of class info, and false otherwise. Multiple inheritance. Python supports multiple inheritance, where a class can inherit from multiple parent classes. This can be a powerful tool, but it can also lead to complex and hard to maintain code if not used carefully. Explanation. Athlete class inherits from both swimmer and walker. Accessing methods. An athlete object can access the swim method from the swimmer class and the walk method from the walker class, as well as its own compete method. The method resolution order, MRO. When a class inherits from multiple parent classes, Python needs to determine the order in which methods are searched when a method is called on an object of that class. This order is called the method resolution order, MRO. Python uses the C3 linearization algorithm to determine the MRO. You can access the MRO of a class using the __row__ attribute or the mrow method. In this example, the MRO of C is C, A, B, object. This means that when you call a method on an object of class C, Python will first look for the method in class C, then in class A, then in class B, and finally in the base class object. Important considerations when using inheritance. Carefully design your class hierarchies. Make sure the inheritance relationships make logical sense. Don't inherit just for the sake of code reuse, ensure there's a true is-a relationship, example a car is a vehicle. Avoid deep inheritance hierarchies. Deep hierarchies can become difficult to understand and maintain. Consider composition over inheritance. In some cases, it might be better to use composition, where a class contains objects of other classes as attributes, instead of inheritance. This can lead to more flexible and maintainable code. For example, instead of having a flying car class that inherits from both car and airplane, you might have a flying car class that has a car object and an airplane object as attributes, delegating tasks to those objects. Use super, prefer using super, to call parent class methods, especially when dealing with multiple inheritance. It ensures that methods are called in the correct order according to the MRO. Document your inheritance relationships. Clearly document which classes inherit from which, and what methods are overridden or extended. This helps other developers, and your future self, understand the code. In summary, inheritance is a powerful tool for code reuse and organization in Python. Understanding its principles, syntax, and best practices will help you write cleaner, more maintainable, and more efficient object-oriented code. Remember to think carefully about the relationships between your classes and choose inheritance only when it truly represents and is a relationship. Consider the alternatives, like composition, when inheritance might lead to overly complex or rigid designs.